Hello, so let's suppose now I've got 8 objects to choose from. Okay, now if I've got 8 objects, how many ways are there of arranging those 8 objects? Should be ingrained in your heads by now. It's 8 factorial. Okay, so I've got 8 factorial ways of arranging those 8 objects. But now, unlike the first video, let's suppose I've only got 3 positions to put them in. So I've only got position A, position B, and position C. So I've only got position A, position B, and position C. So I've only got 3 positions to put them in. Unlike the first video where I had 8 objects or 5 objects and I had 5 positions to put them in, I haven't got 8 positions to put them in anymore. I've only got 3 objects that I want to fill. So I go about it in exactly the same way though. How many objects can I put in position A? I'm going to fill them from left to right. So how many objects can I put in position A? Well, are you happy that I'm going to have 8 objects to put in position A? Because I've got 8 objects to choose from over here. Okay, so let's suppose I put the red cube in position A. Let's suppose I put the red cube in position A. So how many cubes have I got left to choose from to put in position B? Well, I've got 7 cubes to choose from to put in position B. I've got 7 cubes to choose from to put in position B. Yeah, this should just be a reminder of the first video. So let's suppose I put, I don't know, let's put the purple cube in position B. So how many cubes does that leave to put in position C? Well, I've got 6 cubes to choose from to put in position C. I've got 6 cubes to choose from to put in position C. So let's suppose I put the yellow cube in position C, and that's it. I've got no more positions to fill. So all I do then with these 3 numbers, as you've seen before, I just multiply these 3 numbers together. So in other words, I've got 8 times 7 times 6, and then I stop. So once I fill that's the number of ways of arranging those 3 objects. The number of ways of arranging those 8 objects into those 3 positions is 8 times 7 times 6. Now this looks a little bit like a factorial. Okay, this looks a little bit like a factorial, because if I write out 8 factorial, if I write out 8 factorial down here, or down here, so 8 factorial is equal to 8 times 7 times 6, okay, and then if I write out the rest of the factorial, times 5, times 4, times 3, times 2, times 1. Now, that bit looks like that bit up there. Okay, so you're happy then? It looks like when I'm looking at putting, my 8 objects into my 3 positions, putting my 8 objects into my 3 positions, it looks like I start off like a factorial, but then once I fill my 3 positions, I just give up. I kind of lose interest and I just give up. So if you like, there is a factorial hidden in there. So if I write out the rest of the factorial, times 5, times 4, times 3, times 2, times 1, okay, there is the rest of the factorial hidden in there, but I kind of remove it. I don't bother with that, okay, because I've filled my 3 positions in, I've got what I'm interested in, then I just give up, right? So how am I going to write that? Well, it's just 8 factorial, okay, divided by this bit here, which, are you happy, is just going to be 5 factorial. So it's 8 factorial divided by 5 factorial. So this is the number of ways of arranging, or this is the ways of arranging my 8 objects into 3 positions. 8 factorial divided by 5 factorial. Now, how did I get that 5 factorial? Well, the number of positions which I had was 3, okay, and I had 8 objects in total. So 8 minus 3 equals 5. Yeah, that's sort of fairly obviously, my 8 minus 3 gives me my 5 factorial. So if I wanted to do this generally then, if I had n objects, okay, but I only had r positions to fill, then the number of ways of arranging those n objects into those r positions is just n factorial divided by n minus r factorial. Maybe I should do that as n minus r factorial. Let's just get my color coding right. N minus r factorial. So that's the number of ways of arranging it. And actually this is so important. That it's given its own special notation, and it's called a permutation. Okay, and it's actually given sometimes notation NPR. Okay, so NPR is just n factorial over n minus r factorial. It's the number of ways of arranging n objects into r positions. Number of ways of arranging n objects into r positions, and that is called a permutation, NPR.